All right, for this one, it says, for every positive real number x, y, and z, which of the following expressions is equivalent to x to the 1/2, y to the 3/4, and z to the 5/8? Okay, so there's one key fact about like exponents that you need to know here. If you have an exponent with a fraction, okay, as the power, then that means, so let me give you some examples. If it's a fraction, the number on the bottom is your root, okay? Maybe watch that part back to understand what I just said. The number on the bottom is your root, okay? The number on the top is the exponent that would go with the variable. So let me give you a couple examples over here. So for example, say I have x to the 1/5. X to the 1/5 is the same thing as the 5th root of x, okay? Because it's technically x to the 1st, but you can just leave it as x. Because again, the denominator in this fraction goes with the root, and this number, the numerator, goes with the power underneath that root. Another example, say I have a to the 3/7. Again, the denominator is your root, so this is the 7th root, and then it's a to the 3rd underneath. Okay, so the denominator goes with the root, the numerator goes with your power. Okay, so that's a fact you have to know to do this. That's the fact you have to know to do this problem. If you know that, that makes this pretty simple. But there is like some GCF stuff we have to do here. Okay, so coming here, because if you notice, so let's talk about what these would each turn into, okay? If we were just going straight one by one, this would become the square root, which is a little 2, of x. This would become, again, the denominator is your root, so this would become the 4th root of y to the 3rd, because the numerator is your power. And this would become the 8th root, because again, 8 is your denominator, the 8th root of z to the 5th, okay? But if you notice, none of your answers look like that. All of your answers have the same root, or sorry, the same root. So what that means here is we're gonna have to change each of these to have the same denominator, because your root comes from your denominator. So this is just a GCF problem. So I'm gonna rewrite this. X to the 1/2, y to the 3/4, z to the 5/8. Okay, so we need to find the common, or the GCF of 2, 4, and 8. So obviously, or sorry, is it GCF? Or least common multiple? I don't know. We need to find the, actually I think it's LCM, not GCF. I get those two terms confused. Anyway, we're trying to find the smallest number that all 3 of these will go into. Yeah, I guess it would be LCM. Least common. Anyway, whichever it is, 2, 4, and 8. Obviously 8 is the smallest number, or yeah, is the smallest number that all of these will go into, okay? So what we need to do is change each of these fractions to where they all have a denominator of 8. So that means x to the 1/2, it changes to x to the 4/8, okay? Y to the 3/4 changes to y to the 6/8. And again, if you're confused here, 1 over 2, to get 2 to 8, you multiply by 4. So that's how we got 4 over 8. Here we multiplied that by 2, and then this already has a denominator of 8, so we can leave that. So now this is what we have: x to the 4/8, y to the 6/8, and z to the 5/8. So now they all have the same denominator. So what that means is we can go ahead and change that to our root, because again, the denominators are my root. So all of these are to the 8th root. So I'm going to put a giant 8th root around it, and then whatever the numerators are, those just are my powers of each variable. So x has a numerator of 4, so that's going to be x to the 4th. Y has a numerator of 6, so that's y to the 6th. and z has a numerator of 5, so that is z to the 5th. So we have the 8th root of x to the 4th, y to the 6th, z to the 5th. If I look over here, that makes my answer D. Okay, so fact you have to remember again is your new denominators are your roots, your numerators are your powers.